Hello, my name is Evelyn Gallardo and my topic is music. My question is, what is the difference in sine waves in a soft or loud song? I chose this topic because music is something that many of us like and listen to on a daily basis. I believe that music holds a lot of influence on anyone who listens to it. Music is a very diverse form of art and it holds a lot of meaning for many people, especially for those who consider it a therapy for them. This is why I became interested in sound waves and how they differ in different songs. Okay, so what is a sine wave? A sine wave is a mathematical curve that is used to model and predict the rise and fall of tides. In music, a sine wave is the building block of a sound. A sine wave in music can be determined by various factors including repetition of a wave's pattern, which is the cycle, number of cycles per second, which is the frequency, the duration of one cycle, which is the period, the length of a period of a wave, which is the wavelength, and the measure of a wave's change over a period, which is the amplitude. Here is an example of a sine wave, and just to refresh your guys' memories, we studied sine waves last year in Algebra 2 and then again earlier this year in Pre-Calc. There are many factors that come into play when answering my question, which is, again, what is the difference in sine waves in a soft or loud song? So there are two factors in determining a sine wave in a song, which are pitch. The pitch correlates to the frequency of a song's wave, and volume. These two factors determine the difference between a slow song and a fast song. This being that a slow song has a lower pitch and volume than a fast song. In a song, a sound wave is a sine wave. So the basic equation for a sine graph is fx equals a sine b times x. The equation of a sound wave is ft equals a sine times the frequency in hertz, 2 pi times t. Every time a chord is played, the graph of the sine waves become taller, increasing in amplitude. If you increase the value of a, the waves get taller. If it decreases, the waves get shorter. In music, amplitude equals volume. If the music is louder, the sound waves will be taller. This means that in a song that is louder, the sound waves will be taller compared to those of a softer song. Because the frequency is also the pitch, this means that the higher the frequency, the higher the sound, which means that would make the period shorter. Frequency explains why a song becomes a lower pitch when it is slowed down. Since the x-axis is time, if the music is stretched horizontally, the period is increased, and frequency has decreased, meaning that the music is now a lower pitch. Okay, so now to put my question into perspective, I chose two different songs, one is slow and one is fast, in order to come up with the sine waves to represent to you guys the difference between the two. Okay, so the slow song that I chose is Moonlight Sonata by Beethoven. In order to determine this song's frequency, you need the equation 32.70 times 1.059463 to the negative 7 power. You get the 32.70 because it is the frequency of the note being played in the picture, which is note C. 1.059463 is given to you in the equation already, and 7 is the number of keys it takes for C1 to get to C2. This equals 21.82, which you will plug into the sine wave equation, which then would be sine times 21.82 times 2 pi x. Once you plug this equation into decimals, or once you graph it, this is how the graph will look. Okay, so the fast song that I chose is Angel's Song by Deborah Harry. This song's frequency equals 180 per second, which then equals 1.8 hertz frequency. You then plug in the 1.8 into your sine function or equation, and that would give you sine times 1.8 times 2 pi x, which then gives you this graph. So as you can tell, the difference between a soft and loud song sine waves is simply that the loud song sine waves are taller and the soft song sound waves are more horizontally stretched. I hope this video was helpful in understanding the difference in sine waves between a fast or slow song. My name's Evelyn. Thank you for watching.